Hello, everyone. Hope I'm coming through. Hope everyone is doing well today. Welcome to Hoot number 47. And today I will talk about certificates in Istio. If you're here, make sure you post a comment, say hi. That way I know I'm not talking to myself only. But all right, let's get started. So as I said, I'll talk about certificates in Istio today. Um, what I'll do is I'll briefly explain what the default installation does in regards with the workload certificates, and then I'll go through the scenario of rotating the CA certificates without any downtime, and then at the end I'll also show you how to use cert-manager and Istio CSR for your CA and workload certificates. Hey Marino, hey Arco. Nice. I'm not alone, so that's good. It's always good to know I'm not talking to an empty room, I guess. All right, so before I go into that topic, I need to briefly talk about just identity, just so to set the field so everyone knows, everyone has the basic understanding of everything. Um, in terms of identity, and you see Spiffy here and Spiffy IDs, I talked about Spire and Spiffy more in like a couple of weeks back in a previous Hoot. If you want to go and check that one out. But just for this talk today, now the workloads and mesh, for them to use mutual TLS, and in order for us to enforce any access control policies, we need some sort of an identity. And in Istio, this identity comes in a form of a Spiffy ID, and that Spiffy ID gets encoded into an X509 certificate that gets signed by a trusted authority. So Spiffy ID, Spiffy cluster local, and as default SA HTTP bin on the slide here. It's just a string that it uniquely identifies a workload. And Spiffy itself, it's just a spec that describe how and where to encode that Spiffy ID inside of an X509 certificate. So when we're talking about, so we have the identity, we have the workloads, we have the Spiffy IDs, and we have the certificates rather. Now, when we talk about uh, delivering those certificates to workloads, there are three components that are involved here. The SDOD, or the control plane, specifically the component inside of the control plane called Citadel, the Istio agent that runs in, it's a binary that runs in the Istio proxy, and the Envoy proxy itself. So Citadel acts as a certificate authority that signs and issues the certificates to workloads. The Istio agent, as I mentioned, it's a binary that runs in the sidecar proxy, and this binary is responsible for requesting a certificate for that workload and then making that certificate and key available to the Envoy proxy. And the way it does that is via something that's called Secret Discovery Service. That's an API in Envoy. Now, the Istio agent is also responsible for rotating these certificates before they expire. And then finally, we have the Envoy proxy that just connects to the Istio agent and receives the certificate and the key, so it can use for communication. So we know how the rotation, how the issuance of the certificates work. But what happens if I install Istio? I have a default Istio installation, and what happens specifically in terms of certificates, CA, when Istio D starts up? So on startup, Istio D knows about some base CA data, and what it does, it distributes that to each namespace in your cluster in a form of a config map that's called Istio CA root cert. So if you have your cluster, and I'll show you later in the demo, as soon as you install Istio, if you look at the config maps across your namespaces, you will see that Istio CA root cert config map in each one of those namespaces. So that way, once that's in all the namespaces, when the pods start up, what they do is they mount that config map, and then when Istio tries to talk to Istio D, Istio D will present its certificates. The agent can then accept that connection. Now, I mentioned the some base CA data that Istio knows about. Now, by default, Istio D, when it starts up, it's going to self-sign the CA and then use that for signing the workload certificates. However, that's like using anything self-signed is not good, right? So what we can do is we can modify that, and instead of having Istio using the self-signed CA, we can provide our own CA we want Istio to use. So there's a couple of options here. Now, I mentioned that base CA data, right, that Istio uses to push into those config maps. That base CA data can either come in a form of a CA certs secret that's created in the Istio system namespace. So when Istio D starts up, it's going to look for that CA cert secret. And if the secret is there, it's going to take the information from there and push that CA data from that secret to those config maps. The other option is using mesh config. So when you're installing Istio, there's global mesh config settings where you can provide the CA certs directly. And then what Istio does, it'll take those and push those to the config maps. Hey, Edu, welcome. Hope everyone's doing well. Thank you for saying hi as well. Now, as for the external CAs, the two options that I'm going to talk about, both of them will use cert-manager. First one is using the Kubernetes CSR API. So there's a certificate signing request resource in Kubernetes that can be used when requesting the certificates. Now, in this case, when using Kubernetes CSR, Istio D is going to act as an RA. So RA stands for Registration Authority that approves the requests, as opposed to the CA, which is the Certification Authority that signs the certificates. So Istio will create and also approve the CSR, and then the cert-manager will sign it. So cert-manager is configured using an issuer to sign that CSR. Now, these issuers in cert-manager represent CAs, and there's a bunch of options that you have that you can pick from. You can pick Vault, you can pick Google CAS, AWS Private CA, and so on. The benefit here with this one and the next option is that the private key is not present in the secrets. You're not storing it in a secret. You shouldn't be storing it in the secret anyway. Instead, it can be stored outside. Google, AWS, Vault, you pick your option. Hey, Deepak, hope you're doing well. And the last one, the last option here that I'm going to mention and talk about, and this is what I'll show as well in the demo later on, is called Istio CSR. So this is another project that you run inside your cluster. And in this case, you're using a certificate request resource from the cert-manager to request certificates. And in this scenario, Istio CSR is going to act as a registration authority, and then cert-manager is going to act as a CA. So the flow is very simple, very, very similar. The difference here is that with Istio CSR, the workloads in the cluster going to talk to Istio CSR directly. They're not going to be talking to Istio D anymore. All right, so this is just like an overview. There's no more text on the slides from this point on, and I have only a couple of slides to explain the concepts, and then I'll go into the demo. I figured having diagrams like this is makes it much easier to understand versus just me being in the command line and typing a bunch of commands. So I'll look at a scenario where I have a default installation of Istio, which means I'm using a self-signed CA. So what Istio is going to do is it will create those config maps, the Istio CA root cert, and the workloads are going to get issued those issued certificates that are signed by that self-signed CA. So let's say I have that default installation. Let's say I start with this one, and then I say, okay, now I want to create my own root CA, and I want to create an intermediate certificate, and I want to use that intermediate certificate as my CA, right? So what do? We use those intermediate certificates. I'm calling them A here or blue, whatever is easier for you. We take those certs, we store them in a secret called CA certs. We reboot, restart Istio. Istio is going to pick that up. It's going to create the Istio CA root certificate in a namespace. And then any new workloads that are going to come up will have that new certificate or certificate signed by this intermediate A. Now, this is all good in theory. However, if any of the existing workloads, A or B, the ones that are using the old self-signed CA, will try to talk to this new service C. So this won't work because the certificates are from completely different CAs, right? Being in this position, it means you'll have downtime, you'll have failure, at least until you don't go and restart all the workloads. So all the existing workloads or old workloads pick up this new, get the new certificate signed by this intermediate A. So let's assume we got to that place magically. All the workloads have the certificates issued by the same CA, so there are no more issues. Everything works fine. Now, let's say we want to introduce, for whatever reason, we create a second intermediate CA. Both of these, A and B, are rooted in the same root. Now, we replace the CA certs with intermediates from B. This gets populated, this gets pushed through. Let's look at the same scenario. Service C comes up. It has this new certificate from intermediate B. However, in this case, the workloads using certificates signed by the old intermediate CA, this will still work because they stem from the same root. So this works fine. If you have a one root, multiple intermediates, if you're swapping or switching out the intermediates, this is going to work. So what you'll do in this case is you can either wait for, I think it's 12 hours, the default rotation interval, and then after like 24 hours, all the existing workloads that used to have previous intermediates or certificates signed by previous intermediates will have the certificate signed by the new intermediate. Now let's complicate this even more. Why not, right? Now let's say we want to introduce a new root, right? So whatever reason, we don't care. We don't want that old root anymore. We want to introduce a new root and a new intermediate from that root, and we push that. What happens? We end up in that same scenario that I explained first, right? Service C talking to service B or service B talking to service C. It's not going to work because it's completely different roots. So how can we solve this? Now, the solution is fairly straightforward. What you need to do is you create a combined root certificate. So the one that contains roots from B and C. However, your actual CA cert and key will still be from that new root, right? So you deploy that. So your CA certs have that combined root certificate that gets pushed into Istio CA root cert, which has two of them now, right? Service A talking to service C or service B talking to C works all good because the Istio CA root cert has combined root certs in there. So once you're at this point, what you can do is you can just, once everything moves over, right, moves to that new root, all the workloads get issued new certificates. Once that happens, you can just remove that combined root cert to only basically just to include that new root certificate. And then you're basically in a scenario like this, where you have a single intermediate and all the workloads are using that one, and there's only one CA root cert in the cluster. Now that will be the first demo that I'll show, and then the second demo will be showing the cert-manager and Istio CSR. I will be doing a self-signed scenario here as well. However, I'm going to use cert-manager issuer to issue that self-signed CA cert. All right, so the diagram might look complex, but it isn't that complex, right? So as mentioned, we're using we're using cert-manager. So what I do is I create the self-signed issuer first, so number one, right? And then I create a certificate resource, and that certificate is gonna drop the certificate files into a secret called Istio CA. Now, from the previous scenarios, we know that we need to provide the root CA to Istio D. The way that we've done that is by just creating the CA certs secret, or just letting the Istio D create a self-signed CA. However, this time we'll create a secret that the Istio CSR will mount in the step 3, and then we'll also create another issuer called Istio CA in step 4. So this issuer will point to the Istio CA secret, and it's going to be referenced by the cert-manager. So whenever the workload certificate is needed or requested, cert-manager will use this Istio CA issuer to create the new certificates. Now, at this point, we can start Istio CSR, and that one is going to mount the root CA, so the one that we extracted, right? And then finally, we will install Istio D, and we'll see in the Istio D settings, we're going to turn off the CA server functionality, and we're going to point a setting, a field called CA address. We're going to point that to Istio CSR. So now whenever Istio agent, a new workload with a proxy comes up, the Istio agent will talk to Istio CSR for any certificate needs, right? Now, this self-signed setup is okay for testing, right? But for like more serious deployments, production deployments, of course, you want to use something like Vault or Google or AWS to store your keys, right? Instead of storing them in Kubernetes. Now, here's the exact same scenario as the previous slide. However, I replaced that CA issuer with an issuer for Vault, so Vault issuer. So now all the root certs, all the intermediates, all those secrets are basically stored in Vault, and they're not stored in Kubernetes anymore, right? They're not stored in Kubernetes secrets, which is what we want, right? You don't want to be storing these secrets in the cluster. So just like before, we have cert-manager, we have Istio CSR installed, and this time we're using this Vault issuer, and this Vault issuer is configured and knows how to connect to Vault and issue the certificates based on the CA that's stored there. Istio D, just like before, sets the CA address back to Istio CSR. So whenever the workloads are requesting the certificates, they'll go to the Istio CSR directly, and then Istio CSR in turn uses the Vault issuer to issue a new certificate to workloads when needed. All right, so this was enough diagrams. Yeah, I like these diagrams as well. It's so much easier to explain concepts like these with diagrams than just showing it in the code or command line. So let me switch to the demo. I'll just need to figure out the sharing here. If there are any questions, feel free to ask at any time, and I'll answer them as I see them. So let me figure out a good. Let's try this one. All right, I'll make this. I find a good. Okay, I think this is fine, right? If uh, if it's not, mention it in the comments if you don't see it, but it should be all good. Everyone should be seeing my terminal now. All right. So what I'll do is I've created the same scenario that I mentioned mm, in the slides. I basically have intermediate A and intermediate B that are rooted in root one. I have the intermediate C that's going to be rooted in a different root, and then in the combined folder, I just have that combined roots in that one file, and I'll show that in more details as I get to that point. So let me just make sure I don't have anything. I don't have anything installed. I'm using kind. It's a single node cluster, nothing special. What I'll do is I'll install Istio. Hopefully it doesn't take too long. And then once that's installed, we'll just do the typical labeling the default namespace. And then I'll deploy sleep and HTTP bin workloads. Let's see, wait for those to come up. And what I'll do next, once these come up, is I'll also deploy a peer authentication policy that's going to set the MTLS mode to strict. So that way, since we're going to be working with certificates, that way we'll know if something breaks right away, uh, instead of like looking at the details of the certificates. It's just much easier. All right, so we have both of them running. Just double check. Yep, and then I'm just deploying the peer authentication that sets the MTLS mode to strict as opposed to permissive. And then to check that everything works, I will send a request from the sleep pod to the HTTP bin. So shouldn't be any issues here. All works, all good. All right, so we're using the self-signed search here. Let's also look at the config map. So let me show you the config maps. Notice there's Istio CA root cert, Istio CA root cert, uh, in all the namespaces except for the cube ones, right? Let's look at the details of that root cert file. So I'm just getting the config map, getting that file specifically, and then piping it through OpenSSL and looking for the issuer. So issuer is just cluster.local. But what we'll do next is I will create the CA cert secret that uses the intermediate A certificate. So let's do that. I clear the screen again. So create secret generic CA certs in Istio system. And then I'm just pointing to cert key, root cert, and cert chain from intermediate A folder. So once that's created, let me reboot. I'll restart IstioD. I think there's even a setting in IstioD that was added recently, I think, that would automatically reload the certs. So this, let's just see. I think it's restarted. It's fairly fast. Yeah, so this was restarted. And then let's look at the logs from STOD just so we can see what was happening there. I'll just grab for this guy. Yeah, so we can see in the logs of STOD that we're using this intermediate A from the exam that was rooted in the example root CA1. So we're not using the self-signed CA anymore, the Istio self-signed CA anymore. So what happens now? These two workloads are still using those previous certs. So if I would try to make a request, this would still work, right? There's not going to be any issues here because they're still using the same certificates rooted from the same root. However, if I delete, let's delete the HTTP bin. So as I delete this, when it comes back up, it's gonna get that new certificate signed by the intermediate A. So this time, if I try to send a request, clear the screen. So same thing, sending a request. This time we get an error. So certificate verify failed, which is kind of expected, right? Because they're rooted in different roots. It should not work at all. So let's just delete. I'm going to delete the sleep. Sleep picks up the new certificate as well. This, both of them are running, and then sending a request just to make sure that it all works. Now everything works, and both are on intermediate A. So the next thing that I'll do is I will rotate the intermediates. So from A, we're going to go to B, and both of them are routed in the same route. Yeah, so Arco say auto reload plugin certs. Yes, exactly. Yeah, you're right. That's the setting that I was referring to. So yeah, so it is there. All right. So what I'll do is I'll delete the existing CA certs, and then I'll create another one, but this time we'll use intermediate B. So let's do that. And because I didn't set that setting, I'll just delete STOD. Oh, now let's double check the logs again. Oops. Copy paste error. So logs from STOD. And we'll see we're using intermediate B now. However, it's still the same route, right? Now let's restart HTTP bin. So HTTP bin is going to pick up the new cert from intermediate B. And once this one's restarted, if I make a request, it should work fine, right? Because both of those are from the same route, right? So there's no issues here. So let's do that final one now. I'll delete sleep as well. So both of them have same intermediates. So what I'm going to do now is I'll switch to intermediate C, but that one was signed by a different route, right? So I'll do the same thing as before. The only difference is going to be that I'll combine the two root certs in one file, right? But everything else is going to be the same. So this is the combined root cert that I'll refer to, and this one is coming from root A, and the second one is coming from root B. That's it. It's all the difference, and then we'll repeat the same delete create thing. Create the CSRs. Note that I'm still referencing intermediate B here, and the only thing that I'm changing is I'm just adding that extra root certificate from that second root into the combined one, right? So no changes here theoretically, only the root CAs have changed. We added one. So let's do this and take that root cert out and just store it in the combined root, and then we can parse it and to make sure that we have two roots, right? We have the first root, and then we have the second one, which is very aptly named as new root. So this is just proves that we have the Istio took those combined that combined cert and then distributed that into the Istio CA root cert Configmap. Let's delete HTTP bin. If we try again, this should work fine. There shouldn't be any nothing should be affected here. And then delete the sleep again. No issues there. Then as the last step, now that we have both of those root certs there, add the last step. What we would do is we would switch over to intermediate C for any new workloads that come up. We're still using the combined one though, right? So let's do this. And now if you look at the issuer in STOD and the logs, you'll see that it's intermediate C and it's the new root, right? And let's restart HTTP bin again. HTTP bin is going to receive a certificate from the intermediate C, while the sleep is still using a certificate from intermediate B from a completely different root, right? However, this is going to work because we have both of those root CAs in that config map, right? The last step here that you would do is you would update the CA certs again, but this time you would remove the combined root certificate. So it's going to only include the intermediate C's root. And of course, you would do that once all of your existing workloads would switch over to the new root or new intermediate, I guess. Hey, Shaik. All right, so let's go to the second demo, and I'll switch clusters. Istio CSR. So empty cluster. Don't have anything installed yet. And this time I'll start with installing the cert-manager. So this demo is going to show how to use Istio CSR and have the cert-manager and Istio CSR deal with the intermediates and root CAs and issuing the certificates. All right, so first one is just going to be installing cert-manager. There we go. So we have the cert manager. Let's check the cert manager namespace. You have the C-injector webhook and the cert manager up and running. And next, what I'll do is I'll create that certificate issuer, the self-signed issuer, right? That I shown in that diagram, right? This is just so much easier to demo than just setting up Vault and everything, but you should for sure go and set that all up. So let's do this is how the issuer, the self-signed issuer is going to look like. Just called issuer. The kind is issuer. There's also the cluster issuer kind, which applies to the whole cluster, but I think the cert manager docs are very prescriptive and are saying start with the issuer first. Issuers are, I think, bounded to a specific namespace, right? So anything that the issuer can issue to is this namespace in this case, right? Whereas if you have a cluster issuer, it's cluster wide. Anyway, so self-signed, right? No settings. We're just saying, hey, this issuer is a self-signed issuer. So let's create this one. Once we have the issuer, we can go and request a certificate. So let me show you that. All right, so certificate kind from the cert manager. We're saying create a certificate called Istio CA. It is a CA. It's valid for 30 days. Drop the files into Istio CA secret in the same cluster. And then there's the private key setting, subject, right? And issuer reference. So we're just referencing that self-signed issuer I created 30 seconds ago. So let's do this. So now the result of this one is this CA secret, Istio CA secret that was created with the certificate, key, and the CA. So if you remember the diagram, what I'll do here is I'm just going to pull out the TLS cert, and then we're going to use this as a CA. Right? So let's do that. I'm getting the secret, and I'm just pulling out the TLS.crt file, decoding it into ca.pem. And then I'm creating another secret that will be used by Istio CSR, or will reference it in the Istio CSR to act as a root CA, right? So creating a generic secret, Istio root CA from the file that we just extracted from that secret that was created by that self-signed issuer. Let's do this. And now finally, what we need to do is we have to create another issuer. So now we've just used cert-manager to create a self-signed CA certificate. But the last thing that we'll do here is we'll create another issuer that's called Istio CA. And this is what the Istio CSR will use to issue that certificates to workloads, right? And this one is pointing to that Istio CA secret that was created. So let's do this. Now that we have all these secrets in place and issuers in place, we can install Istio CSR, right? So this is how this looks like. What we're doing here is we're mounting that Istio root CA secret, right? And a volume called root CA. And then we're just mounting that secret in as the root CA file that we want to use, right? So this is just telling it, hey, this is the root CA that you use when you're issuing certificates. All right, so this, let's just make sure that this is installed. Cert-manager. It's still running. It's going to come up. There you go. It's one of one. It's up and running. And now we can install Istio. All right, so this is going to be a longer YAML here a little bit, but oops, I can scroll. Wait, what? Okay, let me just change the fonts a little bit, and then I'll go back to a bigger font. So this is just the Istio operator default profile. And notice here that CA address. So what we're doing here is we're basically telling Istio and consequently the Istio agents that are running in the proxies, right, to use this as their CA, right, when they're requesting the certificate. And this is just the Istio CSR service name that we just deployed. Right? We're also disabling the CA server functionality in the pilot. And then there's an overlay that just mounts the secrets from the files, not secrets, from the cert-manager, right? So they're mounting the CA root cert and the Istio DTLS. So let's do this. So this is basically just installing Istio at this point. All right, and I can go back to bigger fonts. All right, this one should be good, right? Yes. Okay. All right, so we have Istio installed. Let's just double check. Yep, it's up and running. And then we'll do the same thing as before. We'll label the namespace. We'll deploy HTTP bin. We'll deploy sleep. And let's wait for these to come up. Now, this time, as they're coming up, the Istio agent is going to use that CA address. It's not going to talk to IstioD for the workload certificate. Instead, it's going to go to Istio CSR. And Istio CSR is going to use that issuer to get a certificate that was signed by that self-signed CA that we've created, right? However, if you're using Vault or like an external CA, like a proper external CA, you would have that single issuer, right? And then all your certificates, all your secrets would be stored outside of the cluster somewhere. But the flow would be exactly the same, right? So when the workloads would come up, they talk to Istio CSR. Istio CSR is then using the issuer to go and talk to and grab the certificates for your workloads. All right, so we have those up and running, and what I'll do is I'll just use the proxy config secret command to take out the certificate, to get the certificate basically decoded into the workload cert file. So let's do this, and I should have the workload cert file here. Yes, it's there. And then I just use OpenSSL to just decode it. And then in the output, if I go out here, you'll see the organization here is the cert-manager. The common name was the Istio CA that was set there. And we have the spiffy here as well, right? Nothing has changed. Nothing has changed from the Istio's perspective, right? This is a valid certificate, valid workload certificate. that workloads can use, right? Istio theoretically doesn't care as long as it has this spiffy ID here and it's a valid document. All right, so that was my demo. I think we're like 40 minutes in. Perfect. I was perfect on timing again. If anyone has any questions in regards to this, I'll gladly try and answer them. If not, I'm just looking to post a link to the previous hoot that I did a couple of weeks back, where I was talking about Spire, and that one has more of a more details on like how Spiffy and Spire work in general. And you should definitely, I guess I can show it here, but it's not going to help much. No one's going to copy paste it from here. But if you go to our channel, you should be able to find it there under live. All right. If there are no questions, thanks everyone for joining. Hope this was useful. Make sure to like and subscribe. If you have any questions, you can post them in under the video, or if you have any ideas for or wishes for the topics that we should do next, you can do the same. Otherwise, thanks again, and I'll see you all next time.